We're not looking at attitudes, we are looking at altitudes. And an altitude is when you take a triangle and start at one of the vertices and go down to form a right angle with another side. So whenever you draw a line segment like that, that is called an altitude. And you can do that from all the angles. Now when you start with a right triangle, starting at this vertex and drawing a line down to the side that's across from it and forming a right angle actually ends up going along the side of two of the sides. So it is possible to go along the side of with an altitude. It is also possible to end up in the middle of a triangle with an altitude. So just be aware that sometimes altitudes can be a little bit goofy. So it says here, drawing an altitude through the right angle of a right triangle forms two smaller triangles. These two and the original large triangle are all similar to each other. And this altitude that's drawn in for us gives us, I'm going to have this purple triangle here, triangle number 1. We have the green triangle right there, our second one. And I'm going to have a bigger outer orange triangle, the outer triangle. All three of these triangles, whenever you start with a right triangle and draw the altitude down from that right angle of the first triangle, all three triangles are going to actually be similar to each other, which is kind of cool. And you can see they definitely all have a right angle. The purple one has its right angle right there. The green one has its right angle right here. But what about the other angles? How are they all the same? So let's mark those up. You can see the shortest side here has an angle right there for the orange one. The shortest side here has the same measure angle up here, and then the purple triangle has its shortest side sharing that same angle right here again, and then the other ones are the same. So believe it or not, this triangle, and then the big outer orange triangle, all three of them are actually similar to one another, which means their sides are proportional. So if we're going to do examples solving triangles, solving for x in these situations, how would we actually do that? Let's start by drawing ourselves the triangles that we're working with. We have this little triangle right here, and we know the shortest side of that, and we know the second shortest side of that. So this one's the small, put one little dot there, and this is the second smallest side of that purple triangle. For the, we'll use the same colors, for this triangle over here, our shortest side is actually going to be the 48. So even though the 48 is the second medium length side of the purple triangle, it is the shortest side of the green triangle. The second longest side of the green triangle is x, our unknown. And I like to put these little dots or some sort of marking around these so I can keep in my head how I'm going to set up my fraction later. So we go back to original one. I took the shortest side to the middle length side, and that's going to be equal to the same ratio, the same fraction, same proportion as the shortest side of the green to the second shortest side of the green, which is going to be 48 over x. And then we can solve for x the way we always do, cross multiply and divide. So we take 36 times x equals 48 times 48. 36x over here, just put that together, and then 48 times 48, I have to grab my calculator real quick, comes out to 2304. 2304. And then we divide both sides by 36 to get our answer, to get our x. And our answer is going to be 64. Now we check that to make sure it makes sense. 64, if we plug that back in here for x, should be a little bit longer than 48 because it's a little longer side, and it is, so that seems to make sense. Jumping over to number 2, same type of situation here. We have a medium triangle right here, our smallest side of 48 and our middle length side of 64. And then over on the left we have our small triangle. And for that, our smallest side is x and our middle length side is 48. So same type of proportions. We're going to have smallest side, x, over the second smallest side, 48, equal to smallest side, 48, over second smallest side, 64. Again, we'll cross multiply, so we have 64 times x is equal to 48 times 48. And just like last time, 48 times 48 is 2304. And then we divide 2304 by 64. And when we do that, we end up getting 36. So very much like the last problem, just a little bit different numbers that we got. And we plug that back in, and we expect 36 to be a little less than 48, and it is, so that makes sense once again. So x is 36. Slide down to number 3. You'll see that a lot of the same numbers tend to get reused in these problems just because they end up working out nicely. But we have this little triangle right here. But this time we have the hypotenuse, which is interesting. That's a new one. And we have the big triangle. We have x coming out of the big triangle. So we're going to work with that. Now we have, on the little triangle, we have the smallest side and the hypotenuse. I'm going to give that 3 dots. And on the big triangle, we have the little side of 60 and the hypotenuse of that one, the biggest side, of x. So with that, we can set up our proportions. So 60, the big side, or the little side, excuse me, with x, the hypotenuse, should be equal to, this time 60 is the big side, so 36 is our little side over 60. A lot of the times with these types of problems, you're going to notice that the same number ends up being across diagonal with itself in the proportion, and that's because if you're sharing a side on one of the triangles, it's going to be the bigger one, and on the other triangle, it's going to be the smaller one. So it's pretty common to see that 60 and 60 diagonal, 48 and 48 diagonal, like we saw in the last couple problems. So we have 60 times 60, cross multiply, is equal to 36 times x. 60 times 60 is 3600, equals 36x, divide both by 36, and x is equal to 100. So x is equal to 100. Again, common sense check. It should be bigger than 60 because 60 is the shorter side and 100 is, so seems like a reasonable answer. And let's move on to the last example here. We have our small triangle with our hypotenuse of 15 and our small side of 9. So small side of 9, hypotenuse of 15. And then we have the big triangle again. We've got x, this whole big thing across here. And 15 is the short side. So 15 is the short side, x is the long side. So I'm going to go short over long is equal to my short for the green. So the short one over here is 9, long is 15. When you get to homework and tests, I would highly encourage you to use color. So if you're using Notability to do your homework, use the colors like I am. If you on your test need to use paper, I have colored pencils available. You might have your own crayons or markers or colored pencils. Please use them. I think they make things a lot easier. So finish this off. Cross multiply 15 times 15 equals 9 times x. 15 times 15 is 225. Is equal to 9x. And if you divide both of these by 9, you're going to get 225 is actually 9 quarters. I like my quarters. So that's 25 equals x. So 25 is equal to x. And if this side is 25, it's a little bigger than 15. Seems reasonable once again. So we're going to go with that. We're going to trust our answer.